All right, hello once again. This is Jeff Scott of Rankin Technical College. When I lectured in the AWD1100 C# programming class yesterday, Friday, the 3rd of March, I had problems with the microphone. So the first lecture that I gave, which was on problem number 2, this mortgage application, I think that came out okay. But the ones I did for number 3, the find square root, and number 4, the order exception demo part A, I had problems with. So I'm going to recreate those right now. So number 3, this is, as you can see here on page 538, create a program named find square root that finds the square root of a user's input value. The math class contains a static method named square root, or SQRT, that accepts a double and returns that double's square root. If the user's entry cannot be converted to a double, so you put in something that was non-numeric or blank or whatever, then display an appropriate message and set the square root value to 0. I didn't exactly do that. I displayed a message and then just stopped, but we'll see it in just a minute. Otherwise, test the input number's value. Remember, you cannot have the square root of a negative number because that's an imaginary number. So if the number is negative, throw a new application exception error or exception to which you pass the message number can't be negative. And again, set the square root to 0. But if the input is indeed a double and a positive double, or 0 or above, I guess, then pass it to the math.squareroot method and display the return value. So let's start up a brand new console project that we will call find square root, as it says right there. Now, while this is coming up in class, if you remember, I went and emailed all of you this file that's on the desktop that I've got here. And let me unzip it. I don't think I've got it in unzipped format. And that, I should say folder, not file. And that folder, which is right here, has in there the find square root. It's actually got all of the ones in there. So these are the comments that I just read to you. So I'm copying those. And now I'm coming in and I'm going to make my find square root. I might have one already under my C# folder, so I'm just going to put it right underneath the desktop so I know it's there. Again, this is a console app, and the first thing I would like to do here would be to drop in my comments. So there they are. Same exact things that I just read to you a couple minutes ago. I'm not going to go over those again. All right, so let's just get right to it. So I put everything into main, and the first thing I did was to declare and initialize my one program constant. So I've got const string, and I just called it end program, and I set that equal to end. All right, so that's the first thing. Next, I wanted to declare my I wanted to declare my program variables. And I have 3 of them. First, I've got a string that I called val, and I can set it if I do want to, equal to the empty string. But this is going to be the value inputted by the user. Next, I have a double called number, and we'll set that equal to 0.0. And that will be the val converted to a double. right? And then finally I've got another double, which is the square root, which I'll set that equal to 0.0 also. And that will be the square root of number. All right, and I'm a little anal about this stuff. I like my stuff to line up. All right, so far we've declared one program constant, and we've declared 3 program variables. Now I'm going to read in that value, I should say. But in order to do that, I want to come up to the top of my code here, and I want to add here, the old using static system.console. All right, so we've got that. So let's let's input our value. So we'll say enter a number or to end the program. And that was called end program. Okay. So if this works, and we're going to run it in just a minute, it should say enter a number or end to end the program. All right, then we'll read it in. So let's try just what we have so far. Notice val does not have the squigglies under it anymore, and neither does end program. All right, so, we've got a read line, so that's good. All right, enter a number or end the program. Well, let's put end in there. And the program ends. Well, the first thing is they might put end in, and they might not put it in uppercase. Let me space this out a little bit there. It looks a little nicer. In fact, let's put a \t in there. All right. So we can say readline dot to upper. Now I can put it in. Now I can put it in uppercase or lowercase or whatever case I want. So notice, clean that up a little bit. So now I can type in end in lowercase. Program still ends. All right. So we've now inputted a value. And we input it into a string because readline always puts things into strings. So let's validate the value that we just put in. So we've inputted the val. Now we're going to validate the val to check for program end condition. So in other words, we want to say here if the value that we just put in is equal to end program, which was end. All right. So if that's indeed true, we want to end the program. And we're going to do a system.environment.exit, and we'll give it a 0, which is a normal program termination. All right. So now if we put that in, again, that should run just fine. Now notice if I put in hello, the program ends too, because I don't have anything else that I'm doing right now. All right, so we'll have to fix that in just a bit. Now, if they didn't put this in, if they didn't put in the word end, well, now we have to go and check and see if we can parse this into a double. See if you can legally convert val to a double. Put converted val into the variable number. Okay? So that's what we want to do. So this is an else if not double dot try parse val out number. And again, play computer. What we just said here was if we cannot take that value we just read in, if we cannot parse it into a double, okay? Don't need a semicolon there. So if we cannot do that, we want to do a right line that says inputted val not a double. So let's try that. We know end works already. Now if we put in hello, program is still ending, so something is goofed up with this. I think I need a read line here, and maybe that's what it is. So, val, string val equal read line, dot to upper. If the value we put in was end program, end. Otherwise, if we cannot parse it, give that value. Looks like it's correct to me, but it did not seem to be operating correctly. Input val not a double. Well, that's good. We still aren't telling it to do anything, and that's why we're still having some problems here. All right. Now, one thing we should have been doing from the get-go is this whole thing should have been wrapped inside of a try block. Everything we've done thus far. All right, because we're trying to do it. So we try to input the value. We try to validate it to see if it contains the word end. We try to see if we can actually parse it into a double. All right, this is if you cannot. If this is true, you cannot parse val into a double. All right, so that's that else if. But if we put here an else, then we can parse val into a double. We're still not done yet, though. But this should work without any problem. Number equal convert dot to int 32-bit val. All right. Remember, it is still possible. It is still possible that when we tried to do this, we put in a negative number. Okay, so notice if I run this, that build errors. Oh, it's because I have my try and I don't have any catch. I'm going to change this later, but I'll just put catch exception E. We won't do anything, but that should be enough to make this work. All right, so if we put in hello, we do get that error. Inputted value is not a double. That's good. If we run it again and we put in a negative number, program just ends, but we're not getting an error, which we should. So after we type in that number, remember, you cannot have a square root for a negative number, as it would be an imaginary number, which, since we don't know how to really show those, all right, so if the number is less than 0, so if indeed it was less than 0, we want to throw a new application exception. All All right, so we throw a new application exception. And we're told when we do that to actually give it a value. So we'll say here, number cannot be negative. So now let's try it, and let's put in a negative number and see if we get our error. -3. Oops, I don't want to just say read line there. I need paren. Oh, it would be an unreachable code. We couldn't actually get there because we've already thrown the exception. So that's why we're getting that line that says unreachable. Remember, we said in class that's dead code. All right. I'm hoping that when I get all this finished in just a minute, because we're almost done, that it's going to work, and it's going to work the way we want it to. Again, as I mentioned in class, we're getting to the point where you might want to start doing this. It's a little bit painstaking, but the good news is you only have to do it once. I'm sorry, this is just a little bit of dead time in here, but what I'm trying to do is, again, for those of you who get more out of this, all right, and how much time is this literally taking me? Less than 5 minutes. All right, so that's everything. That's pretty much commented up the wazoo. Now, the program's not done yet, but that's everything we've done up until this point. Again, some people may look at this and say, this is too hard to read. Could you break that up into just maybe 2 or 3 lines? And of course we can. So maybe that's a little bit easier to read. Same thing here. All right. We still don't have very much code we've written. We're not even to 100 lines. So what's left? Well, how about now we've actually come in here, and now we actually do know that it's a number, and we do know that it's a positive number. So we've got that else. This was our if that's if it's negative. So here, positive number inputted, calculate square root. All right, so this will be a final else. Oops. Oh, I do need that. Okay, so if it is positive, pretty simply, we just want to do two things. We want to say the square root is equal to math dot square root of number. And after we calculate the square root, output original number and associated square root. So right line, the square root of was, let's put it to 2 decimal places. So that's number, and that's square root, semicolon, put a backslash n before that. All right, that's everything there. The only thing that's left is we haven't put any code in yet if we catch our actual exception. So we'll say right line, error, and we'll actually print out the error that the system gives us. And that will be E, which is this right here, E dot message. All right, and they did say in the specs to reset the square root equal to 0. I don't know if we really need to do that, but we're going to do it anyway. So let's take a look and take the whole thing for a spin, and then we'll come back and go over it one last time. All right, hello. It's not a double. Why is that? I guess it's because we've only set it to run once. So we could come in here. I didn't do this before. This says try, so let's add one more variable in here. Maybe we don't even need a variable in there. Let's put in here while, let's put in a while loop. While 1 equal 1, and let's try to put this whole shebang here into a while loop. Everything we've got. All right. So now we should hopefully be able to run it multiple times. All right. Hello. Not a double. Tell us to do it again. Well, we know already if we press N that should work. A negative number. Error, input cannot be negative, tells us to do it again. 1, 2, 3, 4.567. It says the input string was not in the correct format, so we'll have to check that. How about 45? That worked. Square root of 45 was, and I think I know what the problem is, so let's put an end. I think I did the same thing I did yesterday. And that is, when we want to convert this, we don't want to convert it to an int. We want to convert that to a double. All right, let's run it one more time, then we'll come back and decompose it, so to speak. Hello, not a double, boom. Negative 13, error input cannot be negative, that worked. 1, 2, 3, 4, 5.67. And it says that the square root of 1, 2, 3, 4, 5.67 was 111.11. Let's check that just to be sure. Now remember, I only did it to 2 decimal places, so this surely won't be exact. So 111.11 times 111.11, which gives us 1, 2, 3, 4, 5.43. Okay, looks pretty good. Now, we can also put in numbers, easy numbers, so we can figure them out. How about 49, which should be 7? And it is. 4, which should be, 4, which is 2. So there's a lot of different things that we can do to test this. And let's put in goodbye, which we should not end it, and put it out, value is not a double, good, end. And the program ends. So looking at this program then, line by line, because we've pretty much gone through all of it, changed it around a little from what I did in class to make it a little bit more versatile. Again, remember our requirements said, create a program named FindSquareRoot. There it is, finds the square roots of the user's input value. All right, we were able to accept a double. If we couldn't convert it to a double, we displayed an appropriate error message. You saw that. That was the error message, which ended up displaying in here. And that was this. We saw when we put in a negative number that we threw an application exception. All right. And that was the number can't be negative. Okay. And we saw that when it was a double and not negative, that the square root worked. So taking it from one more time here. Sometimes I know I have a tendency to go through this in class a little bit quickly. So it might be hard for some of you to get all of it in. So that's why I'm doing this right here. So when everything was in main, we've got one constant, was a string called endProgram that held a value end. We have 3 variables. This is the value we actually read in from the keyboard. This is our attempt to take that value and convert it into a double. If we can do that successfully, then this value is the square root of that value. So again, I put it into an infinite loop. So put program into infinite loop. All right. And then we put everything inside of a try statement. Most everything. So it came up on the screen and it said enter a number or end to end the program. Well, so there, enter a number or end to end the program. That's this right here. If I put in hello, I actually put that in for my value and I hit enter, it says inputted value not a double. And it asks me to do it again. If I put in a negative number, it says error number cannot be negative. So this inputted value, not a double, all right, that's right here. And I don't even think, I could be wrong. Let's comment this out and see if I still actually need that read line right there, or is that just making it a little harder to read? So let's try to run it again. Hello. There, and it just comes up to the next line without me having to hit enter. All right, so that's that. And again, with a negative number, and it says error number cannot be negative. So when we're putting in something that's negative, it is throwing that new application exception for us, and it's saying number cannot be negative. So we had, here was main, and I'll leave that up there literally for about a minute or so. So if you had problems copying that into down in class, you should be able to pick it up there. So there is the constant. There are the variables. We put the whole thing into an infinite while loop. So that infinite while loop, which I didn't put a comment for, starts here. Come on. So it starts there and it ends all the way down here. All right, so there's our infinite while loop. While 1 equal 1. So what do we attempt to do here? Actually we do more than attempt. We take the value that was inputted from the keyboard and we put it into val. And we also take any letters, alphabetic letters that were in there, and uppercase them. Did we have to do that? No. There's other ways we could have tested, but now if we type in end, little end, end with a big E and a little nd, end with all caps, etc. Now that I'm making this check, it will catch all of them. So after we inputted the value, we check it to see if the value they put in there was end, E-N-D. If it was end, E-N-D, we just exit the program. And zero typically means that it was a normal program termination. All right? So if this if is true, we're done. If this if is not true, then we attempt to go in and see if we can legally convert the value we just keyed in to a double. If we can do so, we put the results in a variable called number. All right? If it's not true, which is what we're checking here, then you cannot legally put what's in there into number. We can't parse it. So if I put hello, that's what's going to happen. And you saw that when I ran the program just a couple seconds ago. All right, so the original if saw whether or not what we put in there was the word end. If we didn't, then we attempted to parse it, to take the value, whatever it is we put in there, and convert it into a double called number. If we could not do that, we wrote down a line, inputted val is not, or inputted val not a double, all right, and that was it. Since we're in that infinite loop, we'll go into the loop, we'll run the loop again. If we get down to here, you can parse the number into a double. We know you can. So we actually do the parsing right there, and we say number equal convert dot to double val. But we have to then check, because the number cannot be a negative number, because the square root of a negative number is an imaginary number. So if it is less than 0, we throw a new application exception and we pass along the message to it, number cannot be negative. Notice, since we are the ones throwing the exception here, we need to give it a value. If we just did this, if that's all we did, whoops, we need one more right paren there we go. And we ran the program and we put in a negative number, then it says error in the application. That message, error in the application, came from the system because we didn't give it an error message. But when we come in here and give it our own error message, like this, what was that? So it looks like this. Now notice that instead of saying error in program or whatever the heck that was, now when we run this and we put in a negative number, now it says error, number cannot be negative. Where did it get that from? Right here. It took that number cannot be negative and it passed it into our catch, which wrote error followed by the message we just put in there, number cannot be negative. If this is false, meaning that it is a positive number, Then we come in here and actually grab the square root and then print it out. And again, if we do have an error condition, this should actually say application exception, not just exception. The more specific you can be with the error message you put in there, the better off you always are. All right, one last run to make sure nothing's broken. If I put in nothing, input value not a double. If I put in something that's not a double, boom. If I put in a negative number, I get that error. If I come in and put in a positive number, okay, and I can put in a god-awful number, and it shows me the square root of that number. All right. Eventually, I'll come to a breaking point where I put in a value that's bigger than the biggest int that I can, or double that I can put in. But that's a pretty honking big number. So that is it for number 3, find square root. Hopefully you found that helpful. When I come back in just a minute, I'm going to do 4A, the order exception demo. 4B we're going to do in class on Monday, March 6th, and that will be taped. All right, but that's it for right now.